Hello friends, welcome back, and today again we'll be solving a question related to signaling system, and the question is as follows. uh, and a system is given to us, and the system is yn equal to 0.5 y of n minus 1 plus x of n, and the input to the system is x of n equal to 10 cos 0.5 and pi plus 60 degrees, and we need to find the response of the system at n equal to 0. Okay, so one thing you can observe here is the system y of n. Okay, y of n equals to 0.5 y of n minus 1 plus x of n. It's a LTI system. So the property here that we can use to get the answer is one way is to directly use the convolution and get the answer, or use Z transform to get the answer. And the other way of doing it is, let's say that the impulse response and its impulse response is h of n and its Z transform is h of z. Then h of n and x of n is the input and y of n is the output. Okay, so we know that y of n is the convolution of h of n and x of n. Okay, this is one property, and in Z transform it is y of z is equal to h of z into x of z. Now what we can do here is we can find this h of z, and then we can find this x of z. X of z is simply the Z transform of x of z, and then we multiply by both of them, and then we take the inverse Z transform and we get y of n from there. But see, x of n will have a Z transform which will be very complicated with y of n. Okay, so that way it's going to take a lot of time to do it. So what we can see here is whether we can use a property of convolution, or say property of sinusoidal inputs to solve this problem. Okay, so what we have noticed here is it's a sinusoidal input. Okay, and the LTI system is there. So what will happen is, only when an LTI system it gets a sinusoidal input, the output is also a sinusoidal input output, and in sinusoidal in nature, and only thing that changes is the phase and the amplitude. Okay, it gets modified. Rest of the thing, the frequency and everything else, or the nature of the input, does not change. That's what is written in these three lines. So let us first try to find out what is our h of z. So what is our h of z? So for that, let's write the difference equation. Y of n is equal to 0.5 y of n minus 1 plus x of n. Okay, so what we can do, we can take a z transform. So if we take the z transform, we get this is y of z is equal to 0.5. We can use again z transform properties. It is delayed by 1, so we can involve z inverse. We can multiply by z inverse with y of z, then we get this value, and x of z. So now taking y of z terms to one side and combine and taking it out, we get this. Okay, so from here what we conclude is y of z over x of z is equal to 1 over 1 by 0.5 z inverse. Okay, this is what we get. Okay, so this is the value that we get for, and this is our h of z. Okay, so this is our h of z that we are getting now. So once we have found h of z, what will be our next step? So let's write it again. Our h of z is 1 over 1 minus 0.5 z inverse. So once we have got this, now what we'll do is, we will see at what frequency we need the response. Okay, so that frequency is defined by the frequency of the input signal, and the frequency of the input signal omega is 0.5 pi. Okay, you can see from here. Okay, it is 0.5 pi. So once we get that value, what we can do is, we know that z will be r e power j omega, or it will be e power j omega, or z inverse will be e power minus j omega, and omega we know, so that omega is pi by 2, because 0.5 pi is pi by 2. Okay, so it is e power minus j pi by 2. Okay, now this is cos pi by 2 minus j sine pi by 2. Okay, now you know that cos pi by 2 is 0, so this will be minus j. Now what we can do is h of z at omega equals to pi by 2 we have to write. Now that is going to be equal to 1 over 1 minus 0.5 into, now we have got that z inverse value, it is minus j. Okay, so simply we can put this value here. Now we get 1 over 1 plus 0.5 j 0.5. Okay, now you have got the value at pi by 2. Now what you need to do is you need to find what is the amplitude of this and what is the phase of this, how much amplitude does it add and how much phase does it add. And then once we get that, then how to calculate the amplitude? Amplitude is simply is equal to, so you can get the amplitude, which is the amplitude of this, as 1 over under root 1 square plus 0.5 squared. Okay, this is 1 over under root 1.25, and that comes out to be 0.89. Okay, 44. So this is the amplitude that you will get. Now again, how much phase we will get? That is 0.5 by 1, and this is minus. Okay, so that is going to be minus tan inverse 0.5, and if you calculate this value, it comes out to be 26.565 degrees. Okay, so once you get these two values, what you really need to do is just, as I told you, only there will be modification in the phase and in amplitude. So what you need to do, you need to just multiply the phase that you get and the phase with this amplitude, and you should add this amplitude to the add this phase to the existing phase. So your yn is simply the original amplitude into this amplitude, the one we have got from here, that is 0.8944. Okay, now cos of, as I told you, the frequency won't change, so we can write the first term as it is. Okay, plus 60 degrees. Now you add some phase to that. So what is the phase? So here is the addition of minus 26.565 degrees. Okay, so now you can write this as 8.944. Okay, cos of 0.5 and pi minus plus, how much you get is, you have to just subtract, and you get 60 minus 26.56, which comes out to be 33.44. Okay, so we got 33.44. Okay, so now again if I write it once again, it is 8.99 cos of 0.5 and pi plus 33.44. Now at n equal to 0, at n equals to 0, we get y at y of 0 is equal to 8.94. Okay, 8.94 cos, so this will go to 0, only will be left with 33.44, and that comes out to be 0.94 into cos of 33.44, and it is 7.46. So 7.46 is our answer. Okay, so we get 7.46 as our answer. Okay, this is how we have to solve these kinds of problems. Thanks for watching.